VLSos here. This is a video lesson. I'll be doing a related rates example problem. I have it prepared here. Let's read the context. The base of a 20-foot ladder is sliding away from a wall at 3 feet per second, when the height of the ladder from the ground is 1 foot. How fast is the ladder falling? In most contextual problems, it's best to diagram or draw the situation in order to understand the question. So we're going to draw a wall that meets a ground. This is the structure of the wall. And I've read about a ladder that must be leaning against the wall if the height is going to fall to the ground. And the ladder's distance from the wall is a measurement that I'm thinking of because we're talking about the base of the ladder sliding away. We're going to assume that a wall meets the ground at a right angle. Rereading the problem in order to get information in the diagram about the situation. The base of a 20-foot ladder suggests that the length, which I could call L, is 20. The units are feet. I know that the ladder is sliding away from the wall at a rate, so I'm going to care about the distance from the base of the ladder to the wall, and I'm going to label that X. When the height of the ladder is from the ground is 1 foot. So I'm going to care about the distance from the ground to the top of the ladder. We'll call that the height of the ladder. And I'm going to label that distance H. I have some information in the reading about speeds. Those are rates. The variables that I've chosen here are going to be measures of distances. In the diagram, this is a right triangle. So immediately, before I go and list the information about the rates, I can see that I have a relationship between X and H and this fixed constant L. The length of the ladder is not going to change. And the relationship between these variables is the Pythagorean theorem. H squared plus X squared, the legs of this right triangle, is equal to the fixed distance, the ladder's length, squared. I can list measures for my variables, X and H. And I'm thinking about the time at which the height of the ladder from the ground is 1 foot. I know that time is involved because this distance from the base to the wall is going to change if it's sliding away at 3 feet per second. So there's a difference between the distance and the rate of change of that distance. If I've called the distance x, then I can think of the rate at which that changes relative to time as a rate, or the derivative of x with respect to time, and I've been given the measure of that of 1. It's a positive 1. This distance x is increasing by 3 feet per second. So what is this 1's measure? At the same time that the rate of change of x is 3, the height of the ladder or the top has slipped all the way down so that it only remains 1 foot from the distance. That's a measure, H, of 1 foot. Now I've got the information that the problem has given me. I'm going to look to complete what I expect every related rates problem should include. At a minimum, it's going to be a related rates problem if we have a mathematical relationship that relates two variables. In this case, it's a simple mathematical relationship, the Pythagorean theorem, and it's relating the two variables, height of the top of the ladder and the distance from the base to the wall, h and x. If I have an equation that relates them, then I can relate their rates, or their rates of change, by taking the derivative of the equation that relates the variables. There is always, at a minimum, in a related rate problem, going to be 4 values that you're going to look for. The values of the two variables and their rates of change, or their derivatives. I've been given the measure of h and the rate of change of x. I need to expect maybe that the derivative of h with respects to time can be found. And in fact, how fast is the ladder falling is asking what is the rate of change of h. And this is what this question is designed to figure out. That means that I need to have a value for x if I'm going to use all of this information to finally find dh over dt. How would I find x? I have h's value in an equation that relates them. I could use that equation, plug in or substitute in 1 for h, and square 20 to get the value 400 and solve for x. When I do, I'm going to subtract 1 squared from both sides so that x squared is equal to 399, and get x by itself to be both, because we're doing a square, the positive and negative of a radical 399. But let's make sense of this in the context of the problem. Is it possible for x to be a negative value? X represents the distance to the wall. Distances are always positive. So even though algebraically I get 2 possible values for x, both positive and negative, I'm going to ignore the negative. X is equal to radical 399. At the same time that the height of the ladder is 1, the distance from the wall is a little bit less than 20, and the rate at which x is changing is 3 feet per second. Now I'm trying to find how fast h is changing. I have an equation that relates those two variables. I'm going to take the derivative of it implicitly with respects to time. When I do, I got to treat both h and x as functions of time and apply the chain rule. Taking the derivative of h squared, I get 2h, and then treating h as a function of time, I will multiply by the derivative of h with respects to time. Continuing on, the derivative of x squared is 2x, chain rule, times the derivative of x with respects to time is equal to the derivative of a constant is 0. When we see that we've taken the derivative of the entire equation, the result includes the 4 values that I would expect a related rate problem would include. The measure of the two variables and the two derivatives, the derivatives of those two variables. The information that I have gives me 3 of those values, which will leave the one unknown that I'm trying to find. If I substitute in 1 for h times dh dt plus 2, substituting in radical 399 for x, times dx dt, that will equal 0. And I can solve for my unknown dh dt. I'm going to subtract 6 times radical 399 from both sides. And divide by 2 to get dh dt by itself. This has an approximate value of negative 59.925, and because this is a contextual problem, it's very important to include the units. This is a rate of feet per second. Is this reasonable? It's negative. Did I make a mistake? Is it possible for the rate of change of h to be negative? Yes, because that distance is shrinking. This is the speed at which the height is shrinking. If somebody were standing at the top of the ladder when the base slipped away, then that person would be hitting the ground at about negative, or the speed of 60 feet per second. That's fast enough to cause an injury. Related rate problems you should expect are always going to include a few ingredients. They're very challenging, but if you approach the related rate problem by first diagramming and visualizing the situation, labeling all the known values and any important value that is not unknown, labeling with a variable, and looking for mathematical relationships, often geometrical relationships between those values and variables, and writing equations for them. And then looking at the equations you have, listing the variables and values that belong to those equations, and seeing which ones you can use the equations to get or find out or calculate. Then after that process, you can usually see that you have enough to head towards calculating the final answer that the problem is talking about. It's worth going through a process of investigating what you have and the connections between what you have before wondering, how do I jump to the answer? Reading a problem like this and thinking, well, where is the answer, is going to harm your confidence. Persist.